Okay, let's take a look at functional transformations in mathematics. This is understanding kind of like how a function or a graph transforms and what to watch out for. One thing that I want to mention, Alyssa, is a little bit about interval notation. Now this is what I was saying where the brackets, right? What do the round bracket means? Well, they're always going to be whenever infinity is involved. So if you're including all real numbers, which is what this is, x is belongs to all real numbers, then it's everything from negative infinity to infinity. But say you're talking about something that's representative of just this. So say this is -2 and this is +3. So see that open circle? Sometimes people are going to do a square bracket all the way to a round bracket. They mean the same thing. Basically that one is included and one is not. I'm going to make that a little bit clearer. There we go. And -2 has been included. And everything in between -2 and 3, including the 0 and -1 and 1 and 2, they're all included and everything in between. And so this would be from -2 all the way to 3. I'm not including 3, round bracket, I am including -2. This would look like it's larger or equal to -2, that's what x is, but it's smaller than +3. That's interval notation, just a sidestep. But functional transformations is what I want to talk about. And so that's like when something, like an absolute, we'll get to that in a second, but like an absolute function. So if I have f of x equals the absolute value of x, that's what this parent function is. Also, y equals absolute value of x, same thing. This would be y equals x squared. This would be just y equals x. This gets into sine and exponential, but you get the idea. But this is the absolute value. And this is, say, the parent function. So it's in its natural state of just this. If I transform this, what could that mean? That could mean I make it into y equals x plus 3. I can make it into y equals the absolute value of x and then plus 5. I could do other things like put a number in front, which would be stretching it. So if I put a 4 in front of my absolute value, right, that's stretching or compressing it. You can do a negative to reflect it. And so this parent one is this. And I'd say, let's say this is down 2. All right, and so this would be reflected, right? So I'm going to have a negative, and it's also going to go down 2, and that vertical translation is on the outside over here. We're going to take a closer look at that in a second. Here we might be familiar with this one, but I want you to start seeing it as the number in front of your x is going to do a vertical stretch, and the number at the end is going to be the vertical shift, sometimes called translation. And so that's going to tell you if it's going up or down. If it's, and this is if for anything, right? In a linear equation, if this was the origin, and I wanted to move this entire graph up, then 1, 2, 3, I would have y equals x plus 3 instead of just y equals x. In the example that the absolute one, he went down 2, right? He went down 1, 2. That was the vertical shift went down instead of up. This example, the vertical shift went up. So that vertical shift is telling you if you're going up or down. If it's negative, it's going up. Or sorry, if it's negative, it's going down. If it's positive, it's going up. Very straightforward. In these versions that we talked about, if we were talking about something happening to inside the x, then that's the horizontal one, right? And it's counterintuitive. In fact, if I saw this as my equation, y equals x squared, and I changed it, right? So say this is the same thing, but 1, 2, 3, 4. This is moving 4 to the right. So this would be a horizontal translation. So it's within the x that's going to shift. and we've got 1, 2, 3, 4, right? There's no plus, it's not going up, there's no minus, it's not going down, there's no vertical shift. I'm not saying it's stretching for this time being, but it does move to the right 4. And so when it's a minus, I know you'd think, oh, minus is to the left, right? -1, -2, but it's actually, you're going to shift to the right. And so when you have a minus, like here, -4, it's going to shift to the right. If it was a positive, then it would shift to the left. And that's why we say the horizontal shift is a bit counterintuitive. The stretch is what's happening in the front. I'm going to also include with this email an interactive website. Slightly different. When I'm looking at my H as my horizontal shift, in the website, that the link I'm going to send, it's going to be the letter A. The stretch is going to be the letter C. The D in the horizontal stretch or compression is still the same, but the K is going to be the letter B. That's the vertical shift and going up and down. So here's some examples of the stretch. Sometimes it's trickier. Let's look at a parabola, the quadratic equation. So the blue one's the parent function. That's this. That's y equals x squared. And as you can see, when the number gets bigger, right, it's actually getting thinner or taller. And when the number is between 0 and 1, and those are important things, right? Between 0 and 1, not negative, because negative would then be a reflection. If I had y equals -x squared, then I'd be looking at a reflection. So key to important here is that the bigger the number gets, 2, 3, 4, 5, 6, the thinner or taller it gets, and whether that's a vertical or horizontal. And we can talk about the reason in just a second. And then the flatter or wider it gets is if it's between 0 and 1. And this applies in exponential functions, and I don't want to get into it, but this pattern of the shift, it's all over. So you're not gonna need to, but I just want to get to the idea that this is the transformations is a key part of 1047.